As we listed out few characteristics of ideal op-amp yesterday, as we know that the gain of op-amp is infinite. It's a very important point you're supposed to keep in mind. That is, A is equal to infinite. Okay, and one more important characteristic you're supposed to keep in mind for our upcoming discussion is input resistance of ideal op-amp is infinite. That is, Ri is infinite. So these two points you are supposed to keep in mind for our upcoming discussion. So our upcoming topic is a very important topic, and this topic is the one which plays very important role in our upcoming discussions too. That is virtual ground concept of op-amp. Please try to understand this. This is very important rule, important topic, uh, which helps in our upcoming discussion too. Virtual ground concept. So what do you mean by virtual? Virtual, the meaning of virtual is imaginary, or we can say that which is not real. For example, your dream is not real. That's a virtual world what you're going to be in, and something which is not real, we can call it as a virtual. So we are going to have the imaginary ground in our upcoming discussion. That's what the topic says, the virtual ground concept, where in fact you don't have the ground, but you're supposed to imagine it because of some reason. Okay, because of some reason or some condition, you're supposed to assume or imagine there is a ground. Okay, now let me take one circuit which is made, constructed, or made or built with the help of op-amp. So you know that op-amp has two input terminals and one output terminal. The terminals, input terminals, are an inverting terminal, that is negative terminal, and non-inverting terminal, that is positive terminal. As a standard, what I follow from the beginning, I call inverting terminal as a V1, I call non-inverting terminal as a V2. You follow the same standard. You don't change the name for each and every topic. You call negative terminal as a V1, positive terminal as a V2 capital, and output as a V0, small V0. Okay, now look at here, this is just an op-amp. Okay, now I'm going to build a circuit out of it. What I'm going to call it as an inverting amplifier, because we need this circuit for this discussion. And inverting amplifier, there is a separate topic called inverting amplifier concept. So I'll explain in detail how to construct this circuit, but I'm going to use this circuit as a reference for in order to explain virtual ground concept, where I have used feedback. A feedback means to say that the output is fed back to the input with the help of a resistance, because I want resistance to control the flow of current. And I'm going to ground the non-inverting terminal, because I'm not going to use it. Ground means to say it's a zero voltage. So obviously, if zero voltage means to say V2 is zero voltage, because I have grounded it. And external input, this is a voltage source symbol. The circle, within the circle you have a sine waveform, and I call small vi. Small vi mean to say that it's a representation of AC inputs and AC values. Capital mean to say the DC values, and other end of the voltage source has been grounded, and it has been fed to the inverting terminal with the help of resistance. I call this resistance as a input resistance R. Let me call it as an Ri. The input resistance what I used earlier, that is found within the op-amp. This is different. This is a input resistance which is a part of the circuit. Okay, and since this is a resistance which has been found in the feedback, the output which has been fed back to the negative terminal, so it has been called as a negative feedback. If I connect the feedback to the positive terminal, then I would have called it as a positive feedback. And keep in mind, there is no positive feedback in the amplifier. Amplifier has a negative feedback. So any of the discussion will use only negative feedback. I'll stress on these things, this part in upcoming discussions when we discuss particularly inverting amplifier. And RF means as a feedback resistance because it has been found in the feedback. And I'll show some current which is flowing across input. I'll show current which is flowing from left to right. I call, since it is flowing across R1, I call this current as I1. And even the current which is, I'll show some current which is flowing in the feedback too. I'll call them as a IF, because it's found in the feedback. So there's a feedback current. F stands for feedback, I current. Okay, and this is I1 means it's found in the input resistance or input part. So I call it the input current. So this is a V1. Okay, now V2 has been grounded. So this is a circuit I'm going to use, what we call the inverting amplifier circuit. I'm going to discuss more detail on this in upcoming topic. But this is a circuit I'm going to use it as reference to understand what you mean by virtual ground concept. Okay, so this is a circuit what I'm going to use. Now, as we know from our previous discussion, what is that? Gain of ideal op-amp is infinite. And input resistance is infinite. So I'm going to use this characteristics as if now. And before that, we know that the output equation for op-amp is what? It's a V0 is equal to gain of op-amp into a difference of the input, that is V2 minus V1. This is a general equation, output equation for op-amp. Okay. Now, look at here. If I rewrite this equation for gain, I want to write the equation for gain, then I'm supposed to take this whole thing which has been together with the gain to the other side. When I take it to the other side, it will be divided because it is in the multiplication now. So it will be V0 divided by V2 minus V1. Okay, I've just rewritten the equation, the above equation for gain. Okay, now from above circuit, we know that V2 has been grounded. That is non-inverting terminal has been grounded. So it's nothing but it's a zero voltage. So that is V2 is zero voltage. And we also know from the characteristics, that is ideal characteristics of op-amp, the gain of the op-amp is infinite. So let me write it here. So let me substitute infinite over here and 0 over here in the above equation. Infinite is equal to V2 divided by 0 minus V1. How can I satisfy this equation? How can I prove that this whole equation will be equal to infinite? And we know that what we know, when something is divided by 0, for example, 8 has been divided by 0, something has been divided by 0, it will be infinite. So I want to make such that, I want to substitute such that for V1 so that it will be equal to 0. What will be right substitution for V1? Right substitution for V1, in order to get the answer as a infinite, I'm supposed to substitute V1 also as a 0, so that 0 minus 0 will be 0. So V0 divided by 0, whatever the value of V0 divided by 0, it will give you the infinite. Therefore, I have to assume what V1 is equal to 0 voltage in order to make A is equal to infinite. So what is that? Infinite is equal to V0 is equal to 0 minus 0, which is nothing but V0 divided by 0. So that's how you get infinite. So V0 divided by 0 is nothing but infinite. So what we have done, we have made, or we have assumed V1 as a 0 voltage. V1 as a 0 voltage mean to say that we have 0 voltage mean to say it's a grounded. We have assumed there is no ground here. But we are assuming there is a ground. Assuming means to say we are imagining there is a ground. In fact, there is no ground. So this is the virtual ground what we are going to assume, so that V1 will be a 0 voltage too. so that V1 will be same as a V2. Overall, what we are trying to make is, we are trying to make V1 is equal to V2, V1 is equal to V2, so that a difference of these two will be 0 voltage, so that something divided by 0 voltage will be infinite. So what exactly we have done here, since V2 is being grounded, it's a 0 voltage, we are going to assume the same voltage over here, that is by grounding it. So in fact, in a circuit there is no ground, it's imaginary ground what we are going to assume. That's what we call it as a virtual ground. Virtual ground. In fact, we are trying to make a same voltage V1 and V2 as the same voltage, so that a difference between these two will be 0 voltage. For example, if I take some other example, if V2 would have been 1 voltage, if this is virtual ground, so we are going to take up the concept as a ground. Some other example, for example, V2 has been grounded, V2 has been 1 voltage, then we are supposed to assume the same 1 voltage in the V1 too, so that a difference of these two will be 0 voltage, and V0 when it is being divided by 0, it will be infinite. So gain is infinite to satisfy this condition. So whatever the imaginations what we have made here is a virtual ground. In fact, you don't have any real ground in the circuit. That's all about the virtual ground concept. I hope you understood.